Well, welcome back to another day of our Cloud 2024 refresh. So we're on the DevOps section. So if we look here, and I'll link to this down below, with the Cloud Plus CompTIA, it was refreshed in 2024. So this is the latest, depending on when you watch this video. We've already done pages 1 and 2. We've been working on page 3, and we're now on DevOps. So we're going to try and cover these 4 bullet points. So there's a lot in those 4 bullet points, but let's go. So those 4 bullet points are: explain source control concepts, explain concepts related to continuous integration, continuous deployment pipelines, explain concepts related to integrations of systems, and explain the importance of tools used in the DevOps environment. Now, if we go back, just taking a quick peek, this is 10% of the for the passing of the test. Okay. So, explain source control concepts. Version control. We have things like Git and SVN. They're a way of keeping track of changes, being able to revert back. We're going to get a little bit more into them in additional slides. But you need to be thinking about where you're storing your repository. How does that play into it? Is it local? Is it in your cloud environment? Is it publicly available? No matter where it's at, it should be treated as it is publicly available. So terms, you need to think about commit. That's like saving, branching and merging. That's or forking. So branching, you are tweaking it a little bit, moving it away, and then you merge it back in. Push and pull, and tagging. So what you put on there on your change. So explain concepts related to continuous integration, continuous development pipelines. So continuous integration is the automated building, and you really need to include your quality control in there as well. So you're automating your testing. Continuous development, I've also heard of this as delivery. That's like CloudFormation, Terraform. There's also lots of other technologies that are used in here. So for example, something like Ansible or AWS CodeDeploy. Of course, we've talked about in the past CloudFormation, Terraform, and things like that. So those are, there's lots of technologies here. You even get into things like Kubernetes and the containerization. So automation and orchestration. So containers are heavily used in this area. So you automate your activities and you do routine operations such as updating, scaling up, scaling down, restarting, and creating internal APIs for access. So automation and orchestration. You really need to be doing secure scripting. So no hard-coded passwords in these. Hackers love to find those on your repositories and use your resources and access your system. So no hard-coded passwords. Use of individual service accounts. Password vaults should be used. And key-based authentication, and consider orchestration sequencing. So change and access management. Make sure you have change management in place, that things are being approved, people know what's going on, that there's some type of a change management board, and that your changes are tracked, and even software are treated as assets, and they're in your configuration management database. Patching. So this is where you have features or enhancements that come down. They're fixes for broken and critical infrastructure applications. What policies do you have in there with patching? Do you have a system around after patching to be able to validate that it worked before and it doesn't work now? So we often refer to that as N-1. and that was oftentimes our copy, is what I've referred to it in my career. So we had our production. Our prod copy was yesterday's production. So when production changed, copy was still around in the old format, so that we could validate um, if issues were from patching or not. Rollbacks. How do you go back if something really bad has happened? This is where I really need to tell a story, because patching takes a lot of time and effort to get started, and time is money, and there's lots of people involved. And if someone doesn't do their due diligence up front and there's an issue, and they're like, well, it says here if there's issues, we roll back. Well, they didn't do their due diligence. Can we just solve that issue and go forward? The I really don't like it when the people who don't do their job are the ones who say, okay, everyone else has to do work a lot more because I didn't do the bare minimum up front. So I often have pushed back on rollbacks unless they made sense. And I have had to roll back in the past. Okay, scope of cloud elements to be patched. So are you patching your hypervisors? So this is if you're doing the clouds local, the type 1 and type 2 hypervisors. Are you patching your virtual machine components? Are you patching the OSs? What about the virtual appliances that you have? Networking components, are they all being patched? The applications and software that are running on your systems, is that all being patched? What about the firmware? It's amazing how many people forget about this. Is your firmware being patched? What about the storage components, your disks, your disk firmware? Making sure that you're patching everything and then getting it all done so that things are secure and hopefully perform better. Now, usually it's better to patch than not to patch. That's not always the case. So you do need to have a way to know how you're going to handle patches in your organization. You need to have a policy. So efficient operations, impacts of process improvements on a system. So how are you tracking? Was this good or bad for our system? What are your methods for upgrading? Are you doing rolling upgrades where you're taking one out at a time? Or is it a blue-green or canary? Seeing if it just having it participate a little bit and see how it behaves. Do you have active passive? What type of environments do you have to test these out? Dev, QA, production, disaster recovery, prod copy. Alerting. Do you have alerting going on so that you know what the status is? There's common messaging methods are being used. Do you disable alerts while you're patching, or do you just make sure people ignore them for a short period of time? Is there communication going on between the people doing the patching and the people watching the system? Can you put things in maintenance mode, basically? What are the appropriate responses during normal production and during the maintenance window? What are your policies for categorizing and communicating the alerts? We all like to sleep, so make sure you have good policies to allow people to rest when they're not actually needed. Operation. Confirm and completion of backups. Not only that, backups are useless unless you are actually able to restore them. So make sure that they're restoring. Do you have a lifecycle management for a system? Roadmaps. What are the old versions, the current version? What about new versions of a system? Are you upgrading and mitigating system issues? What about things that are end of life? Do you have a way to help them nicely go away? Dashboards and reporting. Do you have things properly tagged so they show up in the right area? I mean, you can even tag for cost, right? To charge back or show back. What about things scaling up and down, the elastic usage? Are you keeping track of that? What about how fast something is, the connectivity? Is it available? Is it there latency involved? Are you using the capacity that you've scaled to, or is a lot of stuff sitting idle? Are things slow because you don't have enough resources? Are things slow because you have way too many resources and you're just building cache all the time? How do you handle incidents and the health of a system? What's your overall utilization of the system? Are you getting the worth out of the system for what you're paying for it? What is the availability? Are you happy with it? Do you want to spend more money to make it more available, to chase more of the nines? Right sizing. So do you have it set up to be the right size so it's good for performance, it's good for how much you pay for it, and you scale up when you need to and scale down when you need to? Are you horizontally scaling or are you vertically scaling? So once again, horizontal is if you're adding new systems. Vertical is if you're like adding more CPUs to a box. Are you able to burst into the cloud if needs be, if it's running local? Compute. Are you keeping track of how much CPU is required? What about graphical processing units? What about memory? Do you have things in a containerized format so that they can easily move if needs be? Storage. Are you using the proper type of storage? There's all sorts of options here. And some allow for more throughput, more IOPS. Others allow for greater capacity for your dollar. Maybe you need both, maybe you don't. Are you overpaying for storage? Are you underpaying? Do you want to deduplicate your storage, so only store certain items once and just reference them? Or do you want to compress? What type of things are you doing in storage? Or do you, going back, do you not want to do either of those because the throughput is the major factor, not cost? Network. I'm going to take one step back and talk about storage a little bit longer. Maybe people are upset and want to be on the cheap, but they also want performance and they're not happy about that, and realize that you can't control all those factors. So sometimes you either have to pay more or deal with a little bit of a performance impact. Sometimes you can't buy your way out of a performance impact. Sometimes that's just the way it is. And that's a hard fact, but sometimes you can't quite speed things up. You're reaching the realms of what's possible, especially with what knowledge and resources you have on hand. Okay, network. So how much bandwidth do you need for your network? Do you have multiple interfaces? Do you have the ability to add more? So in the virtualization age, we can easily add more interfaces. Latency. Are you seeing performance issues going from certain places to the other? Are you using a software-defined network? What type of edge computing things are you using? Do you have a content delivery network so that instead of coming all the way back to you, it's cached close by where people are requesting the information? So are you optimizing for placement on the globe geographically? Do you have clusters placed properly? Maybe some things need to cache by the end user and other things need to be closer to the office. Is redundancy built in? Co-location options. Are your device drivers and firmware, are they generic or are they specific vendors, or are you going with open source? There are sometimes options. Backup types. Are you getting your backups properly? So you should understand the difference between a snapshot, so just a point in time of the disk versus a synthetic full, versus incremental, just the minor changes or differential from the last. What to back up and where to. So are you backing up? What are your objectives? How quickly do you want to be able to recover? So are you doing an application level backup or a file system level backup? Snapshots can't do some of them as well as others. What about database backups? How are you backing those up? Those are critical. Configuration files. What about where you putting your backups? Are they to tape or disk or object storage? Are you making sure they're geographically separate? So backup and restore policies. Make sure you have your retention, schedules, location, and service level agreements understood. Your recovery time objective, the point in time from when the outage begins to when you're what you're able to recover. So if the outage begins at 5 p.m. And you've lost data, are you okay to lose all the way to 4 p.m. or the entire day? Recovery time objective. Oh, sorry, that's recovery point objective. Recovery time is how quickly you'll recover. So if you're down at 5 p.m., do you need to be back up at 8 p.m. or is it okay to be 8 a.m. the next day? Mean time to recovery. The 3-2-1 rule. 3 copies of data, 2 different media, 1 copy offsite. So just since I misspoke a little bit, recovery point objective is how much you're willing to lose. Recovery time objective is how quickly you need to be up and running. And the mean time to recovery is the average time it takes to get things back up and running. Or the mean. Okay, cool. Restoration methods. Are we restoring in place? So that would require an outage because if we're restoring in place, things need to be brought down to restore. Or do we have an alternate location? Or do we just have files that we're doing, or is there a snapshot? So how are we going to restore? And you should test this. If you're restoring in place, you can't test it on production. You'd have to do it in alter. But are you doing it in your physical location or in a different place, or maybe even from one cloud provider to another cloud provider? Trying to understand how you're going to do that. And disaster recovery comes into play. How are you going to fail over or fail back? Restoring backups. Replicating so that you can do this easily and quickly and not lose too much data. Get that recovery point objective down. Network configurations. Is everything set up so you can flip a switch easily and not have to wait too long? Do you have the geographic requirements set? So with disaster recovery, there's a lot of things here. So do you have a site that is just ready to go? There's equipment there, it's hot. Or is there some things there and so it's just a warm site? It's not quite ready. Or is it cold? There's just not really much there. Those play into what is your recovery point objective? How quickly, how much data do you have to restore? Recovery time, how quickly you need to be up and going. What's your agreement, your service level agreement for it? What are the corporate guidelines? And you need to make sure that you have paper documentation. You have to have your playbook, your network diagrams, because if your systems are down, you might not have access to things. So you need to have them in another area. So explain concepts related to integrations of systems. So this is where message queues and things like that come into play. So are you sending messages from one system to another, or do you have a repository of your messaging systems where messages can be stored and then sent, or even people can come and get them? How is it being handled? and that's usually through APIs. So having those APIs, how are you managing your APIs? Do you have a repository for those? Are they advertised in-house? Do you advertise some of them publicly? Microservices. This is where um, there's a lot of cool things that are going on lately. The idea behind microservices is you create what you need and keep it small so that it is easy to manage, maintain, patch, and update because it's so small, and so it can be done quickly. It's almost the reverse of these huge ERP systems that I've dealt with for most of my career. And so you're able to quickly just modify, tweak, to pull out, replace individual components because they're so small. Does one thing, does it well, and you can even use some of the cool cloud technologies with this, such as functions as a service. So microservices, they're fun to play with. When you're integrating systems, sometimes you're getting the data out. It's not in the proper format, so you need to transform it. So you extract it, you get it out, you transform it, and then you load it in. This can be done on small or bulk loads. Some of the concerns with integrations of systems, you're getting more complex, so security comes into play. But also because you're becoming more complex, you have to pay attention to the KISS principle. Keep it simple, stupid. So I believe that's what they... so keep it simple. Trying to make sure that you don't become too complex. I really like the story of different companies that have meetings to remove complexity in different areas because it just creeps in over time. Okay. So explain the importance of tools used in DevOps environments. So version control, continuous integration, continuous delivery, deployment, infrastructure as code. So these are all heavily used. So we've talked about some of those. So version control, Git, SVN. Of course you have GitHub out there. So are you doing it local or not? Are you using tools for infrastructure as code? So cloud formations, Terraform. What about the continuous development, delivery, deployment, and continuous integration? So are you using things like Azure DevOps, AWS Code Pipeline? You have, there's so many out there. Jenkins, configuration management. We get into Puppet, Chef, Ansible. So there's lots. You should hopefully be familiar with a few of them, played with some of them, but I know there's so much to try and understand and learn and know. With monitoring, what type of things do you have for monitoring? So the Elk stack has been very heavily used. So Elasticsearch, Logstash, and Kibana. But you also have things like Splunk. Elk is the open source free search stack, where Splunk is paid. Logging, you have to be able to log properly if you're going to use these. So continuously looking at your systems, making sure that you're logging what you need so that you can answer the questions that are being asked, and tracking changes to systems. How do you collaborate with these environments too, with DevOps? So making sure there's a way to easily communicate. Oftentimes there's some tracking tools like Jira, Confluence, but even more quick communication tools such as Microsoft Teams or Slack. There's also security tools that should be used to automatically check your code for issues, because none of us are perfect. We all make mistakes. So making sure the proper tools are in place to do that. Look for challenges, unexpected input, memory leaks, all sorts of different coding issues. So you can't secure properly most code that is just not created with security in mind. There's some things you can try, but eventually, if there's issues in the code, some of them you just can't protect in other ways. Artifact management, so making sure that you're also keeping track of all the changes. So especially when you're in a DevOps environment and there's rapid change. So logging, there's collectors that you can send your logs to. You can do simple network management protocol, SNMP, and also syslog. Microsoft has theirs as well. I can't remember what that is. But logging is only good if you're actually doing stuff with it. So analyzing it, understanding the severities, and auditing it on occasion. This means that you need enough people to work on issues as well as learn the systems more so that you can be improving in all aspects, in the logging, in the deploying. Too often we do just enough to get it working and then stop, and that's not okay. Logging, so make sure you're logging all accesses, so authentications to the system, whether they succeed or fail. Make sure you're keeping track of new systems that are popping up. How do you identify that a new system popped up? So network flow, for example, you see a lot of network traffic going to a new endpoint you haven't been watching. That's obviously, and that's not logging to you, that's obviously a problem. So if you have network flow going on, you can catch new systems that maybe did not go through the proper process. Application logging. So oftentimes the best logging comes the deeper in the stack. So network logging's okay, but oftentimes we can't see what we need to because it's encrypted. So you can go deeper and deeper, and when you get to the application where the encryption's not there, you get better information. So automating of all the process and then understanding the trends. So if you see that, hey, this is increasing just slowly over time, that kind of makes sense versus huge spikes. Huge spikes, you think, okay, what caused that? Maybe it was a news report that came out on worldwide news, and so a lot of people hit it, and it's explainable. But if it's not explainable, trying to understand, okay, what happened? Monitoring, so that comes into baselines. You don't know if it's out of the ordinary, if something weird's happened, if you don't know your baselines. And identifying your thresholds. So when do you care, or when are things going to start to get bad? So understanding where your thresholds are. For that matter, what if no one's hitting a system? If it's a production system and it's regularly being hit and then it's just not getting any requests for a while, that's probably a flag that something's going on. And those are ones that are harder for most systems to alert on, is when, hey, we're not getting requests. So what's the problem? Anyway, so thresholds. What is it supposed to be in receiving at that point in time on that specific day? Scrubbing your logs, making sure you're getting what you need and maybe not as much. Make sure they're not in debug mode and you're getting just tons of stuff that's not very useful most of the time. Are you keeping track of performance? So I've created little programs, I guess you could say, that actually tracked the system in a slightly better way for me so that I could understand things better. So understanding your application, how it scales, when it's scaling, when it's scaling up, when it's scaling down, and the infrastructure components that could be affected by that. So this is all about understanding resource utilization, what is being used, what you have available. And it depends on what your actual service level agreement is, defined for the uptime requirements, as well as the realistic load times. What's the performance need to be? That's one that in my career has caused me a lot of headaches. That I learned the system more, but we didn't have an SLA on performance, and some people wanted crazy good performance from a system that couldn't give it well. So we did a lot of things to improve it, but it just depends on how it's architected, and sometimes there's not much you can do. You can put caching in front of it, but that doesn't help if it's a highly transaction data. So it's really hard. Verification of components, and monitoring the activities of those components. So make sure you're monitoring all the right pieces and that you haven't missed something. As well as the service management tool integration. Make sure your service management tool is part of the process. It's nice if your service management tool participates in, or at least can automatically be notified and updated to the development process. So I hope you've enjoyed this. Congrats, this was the long one, and we'll see you in the next one.